So I'm a postdoctoral researcher on the wellness and exercise strand. So my background's in engineering, mechanical engineering. So I've been working on the technology platform to help people exercise. Then I'll be also involved in the health and fitness evaluations, looking at kinematic data, so how people move when they're exercising, and EMG data, it's like the electrical signals from muscles, so how their muscles are activated when they're moving. So the project that we were working on this year was Stepping Stones. Stepping Stones was a exercise program which focused on short bouts of high intensity exercise. Use of wireless sensors, so we record the motion and give them feedback. So these wireless sensors are shimmers, so they connect back to the base station over Bluetooth. And these sensors give us kinematic data about how they're moving. So the participants attach these sensors to their ankles, and when they move we get accelerometer data, gyro data, and then we can tell how well they're doing the exercise, if they're performing it correctly. And all this data comes back to us, which we can then analyse and help improve the way they're exercising. We also have a wireless heart rate shimmer, so we attach this ECG board to the normal shimmer, and then we can attach it to a standard generic polar heart rate strap, and that way while they're exercising we can get back heart rate data, which is very important. So when they're training to do this high intensity exercise, we're trying to get them to reach a target heart rate. So because we have heart rate data coming back in real time, we can see if they're meeting their targets, and therefore training in the right zone and getting the optimal benefits from the training. We're taking in our raw data from our shimmers, so how people are moving. So then we're doing some real-time analysis on that. So we're doing analysis to give feedback to the people, so counting how many steps they're doing. So we measure the motion with the shimmer sensors, then we can give feedback. You've done 100 steps, you've done 200 steps, kind of make sure they know what stage of the exercise they're in, and that this is increasing their motivation, so they get encouragement that they're getting there and they keep on going. We also take in the raw ECG from the heart rate shimmer, and then we have an algorithm that analyzes that and gives them real-time feedback of their heart rate. Again, it's just to show people where they are when they're exercising. Are they reaching the right zone? Yeah. The information from the training sessions gets sent back over a wireless network or a network to the servers that we have, and then they can be viewed by a clinician. They can see how well for each session, how well they're doing, how they're doing, what was the maximum heart rate, this kind of thing, and based on that they can judge whether to change the training protocol in any sort of way. So you get, after every session you can make changes on the training, so it's good. Now that using the data that we've gathered from this first Stepping Stones program, we can refine our exercise program to make sure that we're focusing on the right areas. So in the lab we've gathered loads of data, so we're going to see which biomarkers are changing, how this is affecting people, and focus on those. Briefly, you're stepping on, you do the Wii Fit exercise, you're stepping onto a board. So you're only really getting information when you're standing on that board. Because we're using shimmers, we're getting information all the time. So it's measuring when they're off the step, when they're on the step, the motion in between. So we're getting a lot more information about how the people are doing the exercise by using shimmers over just using a Wii Fit exercise board. And their target heart rate. The next session, the training will be a little bit harder. Just make sure that they're going to get to the right intensity and do them the optimal performance, and do them the most. Biomobius is an open shareable programming environment where you can rapidly develop programs for taking acquisition of data from these sensors, do real-time signal analysis on it, and then give feedback to the participants about how well they're doing, but we'll also log our data for further analysis, so the engineers and such like can look at that data and then make decisions on how well the people are doing.